Welcome to this demo of what's new in Genesys 2005. If you're a regular visitor to the Agilent ESOF website, you're used to seeing this face talk about the Advanced Design System. But as you know, Agilent recently acquired Eaglewear Alonics, the price-performance leader in easy-to-use, PC-based RF EDA solutions. Don't worry, we don't have any plans to get rid of the Advanced Design System, or Genesys, or to even merge the two products. I'll have more on that topic at the end of this video. But first, let's take a look at three significant new simulation and synthesis engines in Genesys 2005. The first is a new synthesis tool for mixers. Eaglewear is well known for its many innovative synthesis tools shown here. I'll select the new Mixer Synthesis module. You start a mixer synthesis by choosing one of 11 topologies ranging from simple passive configurations to complex active models. I'll choose the diode rat race topology and enter the frequencies to design a mixer in a 900 MHz cordless phone. When I click Apply, a harmonic balance simulation is started, which is much faster in 2005. The Help menu can assist you in choosing a topology by providing theory of operation and performance trade-offs. When the simulation is complete, we see the schematic and graphs of the RF and IF frequency spectrums. Mixer synthesis, as with all the synthesis tools, really saves design time. The second new feature available in Genesys 2005 is called the What-IF Frequency Planner. If you've ever had to select an intermediate frequency for a transmitter or receiver, you know how difficult it is to examine all the trade-offs in finding an IF band that is spur-free. Let's look at how quickly What-IF can solve this problem. This is the What-IF user interface. Configuration and frequency planning are done in this window. Let's find the spur-free IF range for a dual-band down converter by setting the number of parallel mixers to 2. So we now have 2 RF bands being down converted to a single IF. We'll set the maximum order to 10, and we'll only look at spurs that are greater than -100 dBc. The Input tab is where we can specify frequencies and mixing plans. Here we're using the CDMA spec for our RF input and IF bandwidth. For Mixer 2, I'll set the RF center frequency to 1960 MHz, the RF bandwidth to 60 MHz, and of course the same IF bandwidth as Mixer 1, and the drive level to -10 dBm. When I click Apply, the graph shows all possible IF frequencies on the x-axis. The red and blue areas show the spurs for Mixers 1 and 2. The green areas show IF frequencies where no spurs are present. You can see there's only one spur-free band available. This is fairly restrictive, so let's see what happens if we use high-side mixing for Mixer 2. We now see 6 spur-free bands. It's that fast and that easy to evaluate trade-offs with What-IF. The sophisticated synthesis technique used in What-IF is leagues ahead of those old spur charts or programs that don't account for IF bandwidth or spurious amplitude or assume that the LO band is independent of the RF band. What-IF really simplifies a task that could have taken weeks to do in the past. The third new feature I want to show you is a transient simulator called Cayenne. With Cayenne, you can now see the time domain response of your designs, like the startup conditions of this 50 MHz BJT oscillator. This isn't just a version of Berkeley Spice tacked on to Genesys. Cayenne is actually native Genesys code, so it's compatible with all Genesys linear, nonlinear, Verilog A, and system models. When I double-click on the transient analysis, you can see the setup window for Cayenne. Cayenne has a hybrid frequency/time mode that provides faster simulation times by allowing you to specify a frequency, even though this is a time domain simulator, where you want the simulation to be most accurate. Another unique feature is a Help Oscillator Start mode that ensures that the simulator is not the cause of an oscillator design that won't oscillate, as can be the case with many SPICE simulators. Well, that's 3 new features in Genesys 2005. There's a ton more. Let me show you just one big improvement that affects all simulations. It's the concept of data sets. If I open the Analysis Properties window for the Cayenne simulation I demonstrated earlier, you see that there is a field for naming data sets. If you type a new dataset name and then change something in your design, like lowering the voltage to this oscillator from 12 volts to 9 volts, the results are stored in the new dataset. You can view the results of different simulations by changing the dataset. There's no need to resimulate. To view the data from multiple simulations, simply add a series to the graph. Type the dataset name and the measurement you want to graph. You can now see that lowering the voltage affected turn-on time and steady-state voltage. I could show you many more new features in Genesys 2005, like vector and matrix math and writing equations, or the fact that building a model is now as easy as creating a schematic and saving it to a library. It's just a huge release. But I want to take some time to talk about Spectrasys. Both Genesys and ADS users can benefit from the impressive technology in this spectral domain RF architecture tool. I've launched Spectrasys, and we're using this complex signal as an input to this dual conversion receiver. You can see the path for the 450 MHz IF and the 140 MHz IF. Note that Spectrasys can use any linear component, including behavioral models, transmission lines, and lumped components. And new in 2005 is the use of subcircuits. This subcircuit consists of a mixer and filters. Also new in 2005 is the ability to include the phase noise characteristics of a source. By placing the mouse over the output port of this IF path, I can graph several characteristics of the signal path, including this graph, which shows the difference between the signal level and the compression point of each component. The passive components, of course, have plenty of headroom, but this amplifier is extremely close to its 1 dB compression point. In fact, if I increase the input power by just a few dB and recalculate, you can see I get a warning that IF amp 2 has compressed. I'll click Show to highlight the problem component. Since all signals, noise, harmonics, and intermods are propagated to every node in Spectrasys, you can see the spectral content of the signal present at any node. When I plot the spectrum present at the input to this amplifier and zoom in on the graph, you can see the 450 MHz IF signal, intermodulation products, and a very strong unwanted 310 MHz signal. The path this signal traveled is shown here. It originated at LO2, which is this source here. It then traveled through the mixer, splitter, and low-pass filter. So the signal traveled this path. Perhaps the easiest way to eliminate this signal is to replace the low-pass filter with a band-pass filter, which I just happen to have here at the bottom of the screen. When I resimulate, you see the 310 MHz signal is reduced and the amplifier is no longer in compression. Of course, Spectrasys can also do budget analysis, but that's a little like saying your scientific calculator can do addition. Even though I've only shown you a few features, I think you can see that Spectrasys is a comprehensive tool for examining trade-offs when designing a system. I think you can also see why Agilent wanted to be able to offer these tools to our customers. They're powerful, and the price performance just can't be beat. Agilent will continue to offer both Genesys and the Advanced Design System. Genesys provides RF engineers with core simulation technologies which we plan to continue to improve. In fact, we've already added several ADS nonlinear models to Genesys 2005. The Advanced Design System will continue to be where we put the most advanced technology on PC and Unix platforms. And while Synthesis and Spectrasys are available to ADS users now, we do plan to eventually add these to the ADS product line. Well, we've covered a lot of ground in these few minutes. If you're in the market for RF EDA software, I encourage you to contact us to get the latest information. We even have a trade-up program to make it easy to migrate to Genesys from other EDA software. And as your needs grow, you can apply 100% of the current list price of the Genesys products you own towards the ADS product line. Thanks again for taking the time to listen. If you're connected to the internet, you will now be taken to a website where you can learn more about the new features in Genesys 2005.